Yeah, so my name is Ray Phan. So I did all my 3 degrees here at TMU, or Ryerson back in the day. So I started here in 2002 with computer engineering, which is why I'm here. Graduated in 2006 the first time, and then did my master's in electrical and computer engineering, finished in 2008, and then I did my PhD in electrical and computer engineering, finished in 2013. So as an undergrad, I mostly focused on intelligent systems, controls, robotics, and communication systems. And then in graduate school, I transitioned towards more artificial intelligence and computer vision systems, basically because I was very curious and excited to build systems build computer systems that could perceive the environment the way humans did. So I currently work in augmented reality, building systems where I research and develop algorithms that can reconstruct the environment for you to be able to interact with it. One of the major ones is the concept of miniaturization, right? So taking some technology or taking something and just progressively make it smaller and smaller. There's several reasons why you want to do that. One is for power consumption. You want to make it more efficient so that it can run longer. And 2, it's cheaper to manufacture, right? So we know, for example, a good technology that we know now are CPUs, like CPU chips in PCs. The very first computer systems that came out spanned entire walls. And over the last century, computer systems have gotten more powerful and they've gotten more smaller, right? They also can focus on processor design, right? So how do you build the right CPU, or how do you build kind of the right chipset to get it to do what you want to do, right? So how do you figure out the right layouts where the chips are going to go? How do you figure out the right instructions or the right tool sets or like things that you want to accomplish for those chips? So what exactly do you want the chip to do? So they're responsible for designing computer chips, planning computer layouts, designing circuits, equipment, and systems, and eventually you can go a little higher up, where you can build kind of mathematical models to simulate how exactly a chip will work, or how exactly information or the bits are going to flow, between the systems. So Magic Leap, we are an augmented reality company, so we actually build our own headsets. We do the entire stack. So we go from building the actual optics, building the actual hardware, building the actual headsets, to the actual software stack that actually will perceive what is around you, and then you render that on the actual device. So I work in 3D reconstruction. So basically what that does is you wear the headset, and it has a bunch of sensors that you typically see in an autonomous vehicle stack. We've got depth sensors, we have cameras, we have IMU that is used for kind of predicting motion as you're walking with the headset. And then it builds kind of a digital twin or digital reconstruction of what is around you, so that you can interact with it with virtual assets. So for example, let's say if you were kind of moving into a new apartment and you wanted to kind of figure out where things were going to go, right? So instead of kind of physically moving around, let's say a couch or a fridge, you can place virtual assets in this room. Maybe the fridge is going to go in this corner, or maybe the couch is going to go in this corner, or maybe I'll hang a TV on the wall somewhere. It's a way of reconstructing the environment and interacting with the environment. So what I do specifically is I do both. So I not only do research and test out or vet out the latest kind of advancements in 3D reconstruction. I also implement, prototype, and I eventually get them into the hands of users as well. So I get to do a little bit of both. Yeah, so what was going on was mostly the unknown. Like it's a new environment, people I've not met before. Like there's potentially going to be some new courses on new material I've not taken, but it was mostly the unknown. Like I wanted to be able to find a niche group of people that I could be myself with, be able to have a support system where we help each other out in terms of assignments or just being ourselves and hanging out. Right, so for me, it was mostly trying to find the right group of friends that I could connect with, and when I saw my schedule for the first time, it was quite overbearing. I would say engineering schedules are probably one of the toughest to deal with in terms of organization. So the two biggest concerns I had was, well, am I going to be able to handle the workload, and am I going to be able to find a group of friends that I'd be able to connect with and have a good support system to carry me through to the end. I needed to figure out how to prioritize what work to do. So for me, typically when there was an assignment or when there's something that needed to be handed in for evaluation, I tried to work on that almost immediately. Like it sounds like a nerd thing to do, but it was strategic in the sense that it would start to pile up if you didn't work on it, if you weren't diligent. So for me, it was a little hard to begin with, but and that goes back to having a great support system too. So having both of those was key to being able to get through. But I did find it difficult, but I did adapt in the end. Never-ending curiosity, number one. As I mentioned previously, with engineering work, like it doesn't stop when you graduate. You're always constantly learning. So one thing that I really love to see in interns or even full-time employees is their never-ending curiosity, especially to learn new things. That is a skill that will always be around, that you always need to be able to be successful, number one. And number two, to never be afraid to admit that you're wrong. If you need help, if you're stuck, don't hesitate. Like, I suppose it's kind of a pride thing where you want to be able to come up with, so let's say you're tasked with a particular, with something to be done in the system, and you have to figure out how to solve it, right? So I suppose it's a pride thing where you'd be like, okay, I can use what I've learned and I can solve it on my own. But there are many factors in play, especially when it comes to deadlines or other things that are dependent on that task. So don't be afraid to raise the red flag if you need help, because most likely when you're asking for help, someone else will have gone through the same thing you've done. And it'll be nice to be able to guide them in the way where you're avoiding kind of the pitfalls that they've faced because they have the experience. So never-ending curiosity, don't be afraid to admit that you're wrong. And most of the time, especially when you are starting out, there is going to be some collaboration involved, because as you're starting out, you're most likely going to be working on some minor feature or some part of the system that other people will rely on. So collaboration is key. So obviously there will be some times where you have to figure things out on your own, but it's a key part of the process to learn how to collaborate and to work in groups. That goes without saying for any kind of engineering work. Yeah, so it's very important that you find a good group of friends or a good social circle to hang out with. Like that to me was like the key, like it was like the fine line between success and failure. Like for example, let's say if you don't do well on an assignment or don't do well on a test, it's one thing to kind of be in solitude, but it's good to have like a support network to be able to kind of deal with those feelings. So I would say finding a good group of friends is key, number one. And number two, it's a cliche, but be organized. Like it's daunting, especially for first year where the course load is not easy. Like I would recommend try to be on top of your assignments, try to be on top of your your labs and your your reports. So find a good group, find a good circle of friends that are supportive, that have kind of the same goals in mind that you do, and try to be organized with regards to your work.